Hey, you 12s, welcome to Friday's session on exercise 9.4. We're going to talk about transition diagrams and matrices, which is pretty different to anything we've done so far, but I promise you it's not super duper difficult. All transition diagrams and matrices is a way for us to track change from one time frame to another. Okay, so if we have a network diagram, for example, just below with E and H as our 2 points, what you notice is these loops or these arrows all have directions, and each arrow that's leaving a point will always add up to 100%. So for example, here we've got one loop that's worth 75%, and then another loop out of E, that's 25%. If you count the two loops out, that's 100%. Okay, just like node H, we've got a 90% loop, and then we've got a line from H to E, that's 10%, and 90 plus 10 gets us 100%. So in this diagram here, where we've got two shopping centers, Eastworld and Highton, all it means is if we're talking about weekly shoppers, well, 75% of Eastworld's shoppers will come back to Eastworld the next week, okay, whilst 25% go to Highton the next week. For Highton, 90% of the shoppers from this week will stay and shop at Highton the next week, and 10% will go to Eastworld Shopping Centre the next week. So it sort of tracks the literally the transition week to week, month to month, year by year, whatever it might be. All right, so different time frames, and from there we can start creating matrices. So what you notice is we've got these statements down here. We'll just color coordinate them. So 75% of shoppers who shop at Eastworld once a week will shop back at Eastworld the next week, which is what we just talked about, and that correlates or corresponds to that 75% there. We've got 25% of the shoppers who shopped at Eastworld one week, they're going to Highton the next week. Okay, so they're not coming back to Eastworld, they're going to Highton. Maybe for a bit of variety, whatever the case might be. 90% of shoppers who shop at Highton will come back to Highton the next week. That corresponds to that 90 there. And then 10% of shoppers who shop at Highton one week will shop at Eastworld the next week. So if you look at that data, which you can sort of assume which shopping centre is probably better, is it Eastworld or Highton? Probably Highton, because Highton's got a 90% retention. People keep coming back, and few people leave to go to Eastworld. And then Eastworld has more people leaving to go to Highton, which suggests Highton might be a better shopping centre based on these results. All right, and then from there we can create our little matrix. So what you notice is with these transition matrices, the columns will always add up to 1. All right, so 75% gets converted to 0.75 because that's what it is as a decimal. Again, if you've forgotten how to convert decimals to, percentage to decimals, you just divide the percentage by 100. Okay, so 25, 0.5, 90 and 10, 0.1 and 9. And we're going to look into how we create these in a moment. There's some stuff here for you to read, which is everything we've just gone through. And the moral of the story of the first example is, well, if we're trying to find X, Y, and Z and finding the matching matrix, what we need to do first is highlight and color coordinate the loops coming out of each point. All right, for example, point A here, we've color coordinated in yellow. We've got one line that's a loop, that's 65%. We've got another line that's going to C worth 5%. And then we've got a mystery line going to B that we don't know. All right, but remember, all these loops that's leaving A, so these two aren't leaving A, they're coming to A. That's why we're not counting them as yellow. All these loops that's leaving A or are in the yellow highlight, they need to add up to 100%. Okay, so if we have 65% and 5% already, what's the value of x going to be? Well, if you said 30% off the top of your head, you're absolutely correct. How do you figure this out without, if you don't know how to, figure it out off the top of your head? You go and say 100 take away what you know. So 100% take away 65 and 5%. That will tell you what x will be. Okay, so the 65 and the 5, you take away from 100, and you get left with 30%, which is what the x percentage will be. Let's take a look at y. Y we've got in light blue, because that's all the lines leaving point B. So we've got one loop, that's 45%. We don't really know what the context is. Could just be people, could just be birds, could be cities. All right, 45% staying in B the next time round. We've got 35% going from B to A, and then we've got this mystery value going from B to C. To find this mystery value, you once again take what you know, the 45 and 35, and you take it away from 100. That'll leave you with 20%. So this quantity here is going to be 20%. The last one, we've got Z here, which is leaving C. So all the lines that's leaving C, we have to color coordinate the same. And what we have here is, well, we've got 50 and 40. So 50% going from C to B, 40% going from C to A. Well, if you can do it off the top of your head, you can figure out, well, that's 10% left. That's going to stay in C. That's doing the full loop. Or you could go 100, take away what we know, which is 50 and 40, which gets us 10%. Now, how do we turn this into a matrix? Because it's a two-part question. So it says, for this transition diagram, find x, y, and z, which we just did, and then find the matching matrix. So what you need to do is you need to draw up your matrix like so. Again, you need labels. It's really important you have current state and then the next state. So for these really abstract and general questions, you always say current and next. So just below current, you're going to write A, B, and C, and then in next state, you've got A, B, and C. Now, how did we get these numbers? What you have to go and take a look at is the direction of the arrows. So if we start at A and we end back up in A, or we go from A and stay in A, well, which would that be? That would be the loop. That's why this 0.65 corresponds to that loop back in the diagram up above. Okay, so this 0.65 is that loop up top. How many people or things go from A to B? If we look back in our diagram, A going to B was our mystery value of X, and we figured out that was 30%. And so this 30% is going to go in this element here, which is 0.3. And then finally, we've got the lucky last going from A to C. Okay, we've got 5%. So we're going from A to C. So that's why this coordinate is, or this element is 0.05. Now you can do that for the rest. So B to A, B to B, okay, and then B to C. You look at those lines, and then what you'll find is it's just decimal versions of the percentage. And then lastly, I think, yep, last one we had in green. At the 0.4, the 0.5, and the 0.1. Really important that you label the matrix. I can't stress that enough. So we know which way is where. All right, without these labels, we don't know where we're starting and where we're going. Part B of the first example. This time they tell us to find X, Y, and Z from this matrix and then draw the matching transition diagram. So gone ahead and already made a start. Remember, each column must equal 1. So each one of these columns has to equal 1. So you have to think about, well, what is what number after you add 0.4 and 0.2 gets us 1? If you're ever unsure, the best way to go about it is you go 1, take away 0.2 and 0.4. All right, so instead of saying 100%, take away 20%, take away 40%, we've just got everything in decimals here. And that's going to leave us with a 0.4 in this X element spot in the transition matrix. For Y, okay, we're dealing with a second column. Remember, the columns all have to add up to 100% or 1. And what we have is 0.1 and 0.6 already. So we go 0.1 and 0.6, take all of those away from 1, and you're left with 0.3 in that Y element. They're always going to give you 2 known numbers. They're not going to leave you with just 1 known number for each column. Okay, they're always going to give you 2 per column. And then lastly, we've got Z here where there's 2 zeros. So what's 1 take away 0 and then take away another 0? Well, if you guessed it, or you just straight out genius, that leaves us with 1. So yeah, that's sort of how we go about problem solving and figuring out these mystery values. I don't think there's any other issues. I hope not. Let me know if there's any questions through the email channels or the comment section. The next part of the question is to draw the matching transition diagram. What we need to do first is you set up little points, so point A, point B, point C. Once you've got the points up, all you have to do is convert the decimals into fraction, sorry, not fraction, percentage. And then if we take a look at this one here, zoom out a little more. This 0.2 corresponds to this 20% here, where A is going back to A. So we start at A, we go back to A. The X here, the 0.4, that's going from A to B. So A to B, this line here is going to be that 0.4 line or 40% line. Okay, and then the other 40% line, which is going from A to C, as we can see, A to C, that's this line here. All right. I'm not going to go and highlight every single one. I hope just highlighting one helps you out already. That's terrible. Let's redo that. Like so. And that's how we've dealt with the A point. And then you do that for B, and then you do that for C. Okay, and then you've constructed a diagram. Now this diagram doesn't matter if you have A here, B here, and then C here, or A here, C here, and then B there. It's all fine, assuming the arrows are all going the right way. Okay. So the next part is, can you actually apply these transition matrices to a real life example? So if we're talking about a certain species of bird's nest in 3 different locations, A, B, and C on a peninsula, the birds change their nesting locations each year according to the transition matrix, where if a bird stayed in location A, there's a 40% chance of them, or yeah, 0.4 is 40%, of them staying in location A the next year. If a bird was in location A this year, there's a 25% chance of them flying to location B the next year. If there's a bird in location A this year, there's a 35% chance of them flying to location C. So that's how you interpret this matrix. You can do that for B, you can do that for C, but I'm not going to waste too much of your time. So let's jump into the examples. It's really important here that we start underlining. We've got some more detail here. It says this year there are 400 birds in location A, which we've underlined in black, 660 birds nested in location B, and 210 birds nested in location C. How many birds nesting in location B this year would be nesting in location C next year? So we know there's 660 birds starting out in location B this year. And that's how we got this 660 from this red underline. Now, we have to look in our little matrix. B going to C. And what you notice is B going to C is right there, 0.25 or 25% chance or 25% certainty that they're going to fly to location C. And so what you do is you take the 660 and you multiply it by the chance of 0.25. And that leaves us with 165 birds flying out of location B to go to location C. And that's how you've applied the transition matrix. Let's take a look at the next one. The next one says, nesting location C, which is 210 birds, underlined in blue. How many is going to fly to location C next year? So we know there's 210 birds. That's why we've got this 210 here. And then we go, well, if they start in C and finish in C, we've got 70% of them still in that same C location. And we multiply the 210 by 0.7, which gets us 147 birds. Hopefully this is making sense. The next one is, how many birds will be in location A next year? So this one, what you need to do is, you need to look at this row. All right, so let's use, no, we haven't used green. So we look at this top row. That's the percentage of movement to location A. You've got 40% of the birds flying from location A staying. You've got 20% of the birds from location B flocking to location A. Then you got 30% of the birds from location C flocking to location A. And so what you do is you take the values underlined above, 400, 660, and 210, and you multiply it by the stuff that we just highlighted in green. So the 0.4 came from the amount that's staying from A to A. The 0.2 came from the amount of birds, the 20% that's coming from nest B. And then the 0.3 represents the 30% that's coming from location C. And you multiply that and you add the answers once you've multiplied it together. And you can see there's going to be 355 birds located in location A next year. Now, the last question is, how many birds will be in the same location next year as they were this year? This one, we have to look at the diagonal. All right, so this one here, let's underline in red. Oh, that's highlighted in red. Actually, we've already used the color red, haven't we, in the underline? Let's use purple. All right, and then, so this diagonal here will tell us the percentage of the birds that's going to stay put in their location, because this is how many, that's 40% is going to stay in A, 55% is going to stay back in B, 70% will stay back in C. And so how we got these numbers were exactly from that diagonal. And where we got these 400, 660, and 210 is from the question that we initially started with, that we underlined up here. And so what you do is you go and multiply them together. Once you've multiplied and got the answers, you add all three together and you get 670 birds. Alternatively, just type it all in your CAS. Just make sure you don't get the times and plus signs confused on these long equations. That's usually where people mostly go wrong. Right, moving on. The last example. So here we've got a train scenario, and we're going to call this matrix T. That's why we've got the T here. Matrix T. If a train arrives at a certain time, certain station on time, the next train has an 85% chance of being on time. If a train arrives at a certain station late, the next train has a 30% chance of being late. So your first step is to create a matrix. Okay, so we've got the T equals from up above. We draw our matrix bracket, and the topic is this current train, or this train, or current train, and then the side panel will be the next train. Okay, so the axis up top is always going to be the present. Okay, and the axis on the side is always going to be the next time frame. And we're dealing with situations where the train is on time and when the train is late. Now, it says, oh, what happened here? That's weird, must have seizured and accidentally drew. So it says here, if a train arrives at a certain time, or a certain station on time, the next train has an 85% chance of being on time also. You know, let's just highlight, this is a debacle, absolute shambles. So certain station on time, the next will have an 85% of being on time as well. So if you've created this matrix correctly of on time, late, for a train to be on time, there's an 85% chance of it being on time again. So that's why we've got the 0.85 here. If a train arrives at a certain station late, the next train will also have a 30% chance of being late. So late and late, 30% chance, which is 0.3. Now, remember how each column has to add up to 1? Well, you would go 1 take away 0.85 to figure out the value here. So 1 take away 0.85 gets us 0.15. And then 1 take away 0.3 gets us 0.7 in the top right, where if the train's late, there's a 70% chance of it being on time. I feel like that's it. That's it for the question? Okay, that's it. So all you have to do is put the information in the correct element spot and then finish off the matrix. And remember that each column always adds up to 1. Right, the last one. This person called Latzlow has the following system for answering multi-choice questions, which I highly would recommend you to not use when there are 5 options, A, B, C, and D, just like a usual exam or multiple choice section in a test. Now, the information we get, he never picks the same option twice in a row. So what we have to do is we have to construct our matrix. We've got the current question he's doing up top. We've got the next question on the side panel. We've got A, B, C, and D up top, A, B, C, and D on the side. Draw the matrix brackets in, and what you notice is he never picks the same option twice in a row. So what that means, if he selects A on the first question, then second question, he's not going to select A again. So there's a 0% chance of him picking A twice. Just like a 0% chance of picking B twice in a row. Same with C in a row, D in a row, and then E in a row. Okay, so he's never going to pick back to back, which is pretty strange, but each their own. Now the next part says if he has picked D, he will always choose C next. Always, definitive. So if he has picked D, he's always going to pick C. All right. So he's picked D in this question. The next question is going to pick C. Again, pretty stupid, no rationale, but it's just how the question goes. If he has picked E, he is always going to pick A next. So if he picks E first, or on this question, he's going to pick A in the next question. Now, this last one's pretty wordy. It says, if he has picked A, B, or C, so A, B, or C in the current question, he tosses a coin to decide which of the next 2 in alphabetical order he will choose next. E.g., if he chooses B, okay, if he chooses B, then he tosses a coin to decide whether he should pick C or D next. Right. So just to show you what that looks like, if he's picked B in this current question, he's got to flip a coin to see whether he picks C or D in the next question. So he's got a 50% chance. And that's 0.5 as a decimal. And that's why it's 0.5 there. All right. And he does that for A, B, and C if he's doing the present question. So that's why the rest of this is also purple. Or going to be purple in 0.5. Cool. So we've constructed the matrix from the information that's given. Now, what do we do with the rest of these blanks? Well, what you notice is each column just has to add up to 1. This one already adds up to 1 because 0.5 plus 0.5 gets us 1. So the rest of the values are 0. 0.5 plus 0.5 gets you 1. So the rest of the values are 0. 0.5 plus 0.5 gets you 1. Rest of the values are 0. Got a 1 here, so everything else is 0. And then you've got a 1 up top in the top right, so everything else will be 0. And that's literally it. See if we've done all the questions. That's all for exercise 9.4. Let me know if you have any questions. And we're probably going to spend Monday on this too. So SAC is now pushed back to week 8 because of the practice exams being next term. And yeah, let me know if you have any difficulties. Thanks, everyone.